afternoon, my YouTube viewers. It's Crystal here. I haven't made a video in a few weeks because I've been busy doing other things. If you subscribe to my channel, you'll know that I was working on some R programming. But in this video, I'm going to be working on Python programming, and I'm working on Kaggle's monthly competition. And so this is Playground Season 6, Episode 1. And basically what you have to do in this competition is you have to predict on exam scores. And I did actually get a bronze medal for it. And not only did I get a bronze medal, I also got a comment where somebody commented about how they didn't know how you can get the shapes of a data frame. And so they were really pleased about the way that I programmed how you can get the shapes of the data frame. So those were two things that happened with this competition question that I entered yesterday, because I was really busy working on statistics, and because I was busy working on statistics, I decided that I wanted to wait until I finished working on this part of the statistics before I did the playground competition, which I did. So you can see that basically I scored 8.76 RMSE, that's root mean squared error, and the highest score was about 8.5, so I didn't score that bad. So we're going to talk about the problem statement. The problem statement is we're going to predict on exam scores, and when we predict on exam scores, you can see that this is a regression problem. And so what I'm doing is I'm using catboost regressor to make predictions on this data set, on the test set. So the first thing that we're going to do is we're going to import the libraries. And so you have to import the libraries at the beginning of the program. So we're going to import NumPy as NP, which is a numeric library that creates NumPy arrays and performs numerical computations. We're going to import pandas as PD, which creates data frames and also processes data. We're going to import OS, which goes into the operating system. We're going to go into sklearn. We're going to import sklearn, and that's going to provide your machine learning functionality. And we're going to import train test split. We're going to import root mean squared error, and we're going to import R2 score. You didn't need fetch California housing. That was an oversight on my part, because what I had done was I wasn't sure exactly how to use catboost regressor, so I got some sample code, and on the sample code they used to fetch California housing, and so I did that in a Jupyter notebook on Google Colab. So you don't need it in this question, but as an oversight, I left it in. And then from catboost, we're going to import catboost regressor and the pool. And the pool is actually a common function in order to make predictions using the catboost regressor. We're going to import matplotlib.pyplot as PLT, which is a visualization library, and we're going to import Seaborn as SNS, which is also a visualization library. So the next thing we want to do is we want to retrieve the files, and we're going to use the OS function to retrieve the files. So we retrieve our files, and we have 3 CSV files, being sample submission, train, and test. And after we retrieve the files, then what we want to do is we want to read in the CSV files. So we want to take in the CSV files and we want to convert them to a data frame. So we're going to convert the 3 CSV files into train, test, and submission. And another thing that we want to do is we want to make sure that we show all the files in the data frame. So we do pd.set option brackets display.max columns, comma, none. And so now what we're going to do is we're going to view our CSV files. So you've got your train data frame, or we're not viewing the CSV files, we're actually viewing the data frame, but I just said view CSV files. And then so basically you got 13 columns of data, and the final column is going to be your exam score, and that is your target. You can see from the 13 columns of data that you've got categorical columns and numeric columns. And since you have categorical columns and numeric columns, I decided to use the catboost regressor. And the reason why you use the catboost regressor is because the catboost model is designed specifically for categorical variable features. So we've got the test data frame, and on the test data frame it has 12 columns of data. The reason why it has 12 columns of data is because the 13th column is missing, and that's because that's the 13th column is going to be our prediction. And then we have our submission. So your submission is going to be your exam score, and this is going to be the format that Kaggle wants to see whenever you submit your work to Kaggle. So now what we want to do is we want to find out information about the features. So we do train.info, and when we do train.info, you can find out whether the column of data is going to be an integer, a float, or an object. And so you can see that the exam score is a float, and we've got 2 integers, several objects, and 3 floats, not including the exam score. So now what we're going to do is we're going to define our categorical values. So categorical features are gender, course, internet access, sleep quality, study method, facility rating, and exam difficulty. So we're going to drop the ID column. The reason why we drop the ID column is because you don't need it. And the reason why is because Pandas automatically indexes every row of data. So you don't need the ID column. So we're going to drop it just to make it easier for the model to make predictions. Then we're going to define our X and our Y variables. Your Y variable is your dependent variable. So Y equals train.pop exam score. So what it does is it pops the exam score out of the train data frame. And X is the remaining columns in the train data frame. And X test is test. So we're going to analyze the target. And how we analyze the target is we're going to create a histogram of exam scores. So this is your histogram of exam scores. And it's similar, it's close to a bell curve, but you do have some a lot of instances in the 20 percentile and the 100 percentile. Now we're going to split the data set into training and validation sets. So X train, X val, Y train, Y val equals train test split, X, comma, Y, comma, test size equals 0.2, random state equals 42. And this is what I received the comment on, because now you can check the shapes of all of the training and the validation set. So you can see that on the training set and the validations, xtrain, xval, you have 11 columns of data. And on the xtest, you have 11 columns of data. And then on the ytrain, yval, you only have 1 column of data. So we're going to create a pool, which is catboost data structure. So train pool equals pool brackets data equals xtrain, comma, label equals ytrain, comma, cat features equals categorical features. And then you have val pool, which is the same format as the train pool. And then you have test pool. So test pool, you don't have a label, but you can use the pool without a label, which is what I did. So now what we're going to do is we're going to initialize the model. So model equals catboost regressor, iterations equals 1,000, but you can make it larger, more iterations if you want. But the problem is that the more iterations you have, the longer it's going to take the model to train the data. So I was in a hurry. I didn't want to spend a lot of time waiting for the data to be trained. So I only used 1,000 iterations. But if you've got the time and you're patient, you can use more iterations. The learning rate is 0.05. That's your step size. Your depth of trees is 6. Your loss function is RMSE. That's root mean squared error. And so what that does is that calculates the noise. And your evaluation metric is RMSE. Your random seed is 42. And your verbose is 100. So what that means is every 100 iterations, it will print out something. So we're going to fit the model. So model.fit brackets train pool, comma, eval set equals val pool, comma, use best model equals true. So we only have 1,000 iterations, and so it goes up to 999. So our best test is 8.77 RMSE, and the best iteration is 999. So if you want to increase the iterations to see if you can reduce the RMSE, that would be a good idea. So YPRED, that's your prediction on your validation model, equals model.predict brackets val pool. And at this point, I would like to say that I also use model.predict YPRED, and the RMSE was exactly the same whether you use val pool or YPRED, but I just stuck with val pool. So we're going to plot the results. You can see these are the results that we plotted because there were a lot of rows of data. And since there were a lot of rows of data, it was a lot to plot. So now what we're going to do is we're going to create a histogram of YPRED. So you can see this is the histogram of YPRED, and it sort of resembles a bell curve, but with a plateau. So now what we're going to do is we're going to evaluate the performance. The RMSE, that's your root mean squared error, is 8.77, and your R-squared score, which is another type of noise measurement or evaluation metric, is going to be 0.7835. So now what we're going to do is we're going to predict on the test set. Pred equals model.predict brackets test pool. And then we're going to create a histogram of the prediction. And so you can see that the prediction looks very similar to the prediction of YPRED. And now we prepare our submission. So submission exam score equals PRED, submission.toCSV, so we convert our submission to a CSV file, bracket submission.csv, comma, index equals false, submission equals pred.readcsv, submission.csv, and submission. So you can see this is the submission, so this is the exam scores. And then so I saved it and I submitted my work to Kaggle. And when I submitted my work to Kaggle, I got an 8.76 RMSC, and it wasn't the best score. The best score was about 8.5, but I decided that I was just going to stick with it the way it is. And you can try to improve the score by increasing the iterations. That is one thing that I would do if I had the time to improve the score. So that concludes this code review of what I did with Kaggle's playground competition question, season 6, episode 1. I will be leaving a link to the the Kaggle page, so you can look at the code if you want. So thank you very much for watching my video, and I will be making more videos for you about data science projects in the near future.